Hi everyone, thank you for joining us for this session on the Microsoft Reactor. We will get started here in just a few minutes, but I have a couple quick announcements. We do have the live event Q&A open for today's event. You should see an icon that has two text boxes with a question mark in it. That is going to be the live event Q&A. Please feel free to ask questions in there, and Jeremy will be answering them throughout the session. We'll also be sharing some links there. We'll be sharing a link to our Reactor meetup pages where you can see more events that we have coming up. We'll share a link to our Reactor YouTube page where you can find the recording of this session as well as other past and upcoming sessions. And then finally, I'll be sharing a link to our Reactor survey. If you do have a few minutes and to fill that out, we would love to hear from everyone. It's great for us to know what you think of the content we're providing, as well as what other type of content you would like to hear. And then Jeremy has a link to some information about today's session, and we'll be sharing that in the live event Q&A as well. So I will now pass it on to Jeremy, and thank you so much again for joining.
Thank you. My name is Jeremy Likness, and I've got my Twitter handle up on the screen. So if you're on Twitter, feel free to reach out to me. I've got open DMs, which means I don't have to be following you to receive your messages, and I'm open to all things. I am a program manager for .NET Data at Microsoft. So I'm interested in all the experiences that relate to data. One of those is our Entity Framework product. And I'm happy to work with the EF Core team on this and share some of the newer features. So this is going to cover what is new with Entity Framework 5.0. I do not have enough time in an hour to cover every feature, so I'll highlight some of the more popular features. But I'm going to pop over, to a website for you. So this is a web page that we will share in the links. This goes to the main documentation. If you go to aka.ms, and I'm actually here, I'll type it in for you. Let's zoom in up here. So if we do just aka.ms efdocs, that takes you to our main documentation page. It's very comprehensive documentation. You can see there's a lot of different categories. One of these, Entity Framework, what's new in EF Core 5.0. This will bring you through all of the major changes that came through, many of which I'll be covering today. So what is EF Core? For those of you who aren't familiar with it, I'll give a quick high-level overview. EF Core is what we call an object in parentheses relational mapper. And I say in parentheses because the original goal of Entity Framework Core was to enable you to take your C# classes, your business or domain classes, and map those to a relational database. Recently, we released what's called a provider or a database connector, if you will, for Azure Cosmos DB, which is a document database. It's not relational. So I always kind of put that in parentheses because we're not just mapping to relational databases. Now, part of the appeal of EF Core is that if you've worked with database code in the past, you've probably done something like this, where you're basically mapping tables and columns. This is right from our documentation, and pulling things. Here we've got a generic object, we've got some data values, we're using magic strings, and although this code works, it's not how modern development practices like to pursue these types of solutions. And what do I mean by that? Well, let's hop over to a sample project and take a look at a very simple model. I basically have contacts, meetings, and then I want the union between them. Of course, a meeting can have multiple contacts, and a contact might be attending multiple meetings. You can see these are just straight C# classes. I'm not doing anything with a data set or a data reader. I'm just defining what my model looks like. There is one aspect of this that I'll say is a little artificial, and that is simply that for a contact, I'd really like to just point to the meetings that contact has. And for the meeting, I'd really like to point to the attendees. So you can see these properties here. What I've done, and this is something that older versions of EF Core required, is I've created this class that's sort of like a join table class. In other words, it points to a contact in a meeting and says these two are related. I call this artificial because this class really only exists to make the database happy. Now, I'm going to talk more about that in a second, but let's look at Entity Framework Core itself and how it's set up. Again, assuming that you haven't worked with it before or don't have a lot of knowledge about it, this project, this is the project file. It's very simple. It's a .NET 5 project. I'm using the latest version of C#, and the only thing I've included is this reference to SQLite. So this is Entity Framework Core SQLite. And we have different providers depending on the database that you work with. So there's a provider for SQL Server, SQLite, MySQL, PostgreSQL, Azure Cosmos DB, and there's other commercial providers and community supported providers as well. So there's a lot of flexibility with how you can connect to those databases. That's it for my project file, for my setup. In my program, I do one additional step to join my C# models to the database, and that's this thing called a DB context. I inherit from it. It's provided from EF Core, but the DB context is where I tell EF Core what I'm interested in. I may have a project that has 500 classes in it, and I probably don't want to save all 500 classes to the database. So what I do with this DB context is I use something called a DB set to tell it, hey, this is an interesting entity. I want you to track contacts, and I want you to track meetings. Now notice I didn't include this meeting attendee, and that's because EF Core is smart enough to look at those classes and understand that there's a relationship there. So it will go ahead and pull in that join table, if you will, to the model, and I'll show you what that looks like. So this is it for defining my domain, if you will. I've got my two classes and I've got my DB context. So how do we work with the DB context? Let's go to the top of the code. First thing I'm doing is I'm configuring my DB context. One of the features that EF Core provides is this fact that you can attach a DB context to different database providers. So in this case, I'm using SQLite, and you can see I'm in my options saying use SQLite right here, and I'm giving it the name of the local SQLite database. If I wanted to use SQL Server, I would simply configure this to .use SQL Server. So I can take that same DB context and configure it in different ways. Here I'm just creating an instance of the context. Now EF Core deals with databases in several ways, and there's three approaches people typically take to managing their databases. The first approach is they define everything in code and then just ask Entity Framework to generate the database from the code. So that's one approach. Another approach is the database is defined and they ask Entity Framework to generate the C# classes from the database. And that's a possibility too. It's called scaffolding, and it will look at the database and generate those. With either of those approaches too, there's also a mechanism called migrations that lets you manage how your schema changes over time. I'm not going to get into migrations because I'm keeping it a little simple and we have limited time, but just know that that's there. The third way, which is my favorite way, is to define your classes, define your database, and then use what's called model builder to define how those map together. In other words, you don't have to just generate blindly from your code. You can give Entity Framework Core some instructions on how to map that code, and we'll take a look at that. These two lines are just making sure the database is there. You would not do this in a production application because every time this runs, it's deleting the database and recreating it. I'm doing that for demo purposes so that I can show you how changes evolve over time, but just know that you would use a different mechanism for a production. Now, this code base is creating 3 contacts, Jeremy, Maria, and Doreen, and it's creating 2 meetings, a work stuff meeting and a bank meeting. And then it's using these join classes to indicate that Jeremy's at the work meeting, Maria's at the work meeting, Jeremy's at the bank meeting, Doreen's at the bank meeting. This is how I tell Entity Framework Core to actually make a change. By adding these entities, and notice that I've mixed and matched different entities. These are contacts right here. These are meetings, so I can add different types of classes. But by adding this range to the context, I'm telling EF Core, these are classes I want you to keep track of. And then when I say save changes async, it automatically looks at any changes that happen, which in this case I've created brand new classes, and it generates the database code necessary to make that happen. And we're going to take a look at that in a minute. Here I'm just resetting, I'm sort of emulating what would happen in a production app, so I've got a fresh state. And then I've got a query, and what this query is using is LINQ, or Language Integrated Query. This is another benefit that many people use EF Core to take advantage of, and that's the fact that you can use this strongly typed query language to query your database. In other words, I can take this statement and EF Core will translate this and turn it into the database dialect, whether it's a SQL API for Cosmos DB or the T-SQL for SQL Server or SQLite. It understands how to translate this and pass it to the database. So what am I doing here? I'm starting with my context because I want to interact with the database, and I'm telling it I'm interested in this list of contacts. I'm telling it to include the meetings, and the meetings itself, that's that pivot table. I want it to include the meeting information. So give me the contacts, give me the meetings that they're connected to, and give me all of that underlying data with that. And just give me 1 second, just seeing if questions come in here. Okay, so then I'm turning this into a list and I'm iterating through and I'm just writing out the contact name. So very simple, few lines of code, all contained in one file. This is my application. So I'm going to hit F5 to run it. And we'll let it spin through, do some tasks. It's running, running. And we'll scroll down to the bottom. And here you can see it basically pulled out, the query I asked for was give me the contacts who have work meetings and then show me all of their meetings. So because I had a work meeting, it showed my 2 meetings. And because Maria had a work meeting, it showed Maria's single meeting. So this worked, but let's see what happened underneath the covers. So I'm going to collapse this window, and I've installed an extension that lets me look at a SQLite database. So if I open that extension, I can open this meetings database that was generated, and then we can explore the database right here. Let me collapse this and expand that. So you can see I have a contacts, a meeting attendee, and a meetings. And we can see the definition. It has an ID and a name. So it's figured this out just by looking at the C# classes, what to do with this. If I press play here, it'll show me that this is a link table that's linking these together. So that's the basics of how it works. Now I'm going to go into some of the enhancements and updates that we've done. The first thing I want to do is I'm developing a new application and I want to understand how this is translating my request to the database. So here I have a query, and I'd love to understand how that query is going to operate when I turn it into a list. So what I'm going to do is set a breakpoint right here. Actually, this will be easier to see in Visual Studio. So let's open this app up in Visual Studio. And then I'll drop back to code so that you can see this project works just as well in VS Code and Visual Studio. And don't worry, I'll zoom in on the font size where we need to. So I'm in Visual Studio. I'm opening this program .cs. Let's zoom in a little bit for you here. Okay, so I'm going to put a breakpoint right here, right after I define the query, and I'm going to run this. So I've got another window that popped open. It's compiling the application. It's starting to run. And now we've landed on this statement. So one of the powerful features of NED Framework Core is that if I hover over this work context query, you'll notice that there's a property on this called a debug view. And that debug view gives me insights into what's going on with that query. In fact, if I expand it, I get two things. I get an expression, which is telling me basically how I defined this query in my code. This looks very similar to the code that I wrote. But the other important thing that I can expand is if I come in here and I look at the query itself, it's going to give me the exact query that it's sending to SQLite. So I've got a parameter, and then I've got this select statement with a join. So I'm just going to grab this, and I'm going to copy that, and then I'm going to stop this session. And let's go back into our SQLite, and let's do a new query. And I'm going to paste this in. And the only thing is I didn't grab the parameter here, so I'm going to hard code it instead of parameterizing it just for the sake of showing this. But I'm going to say work meeting. And then we can run query. And looks like we're a little turbo zoomed in. Oh, it was work stuff. It was bank meeting and work stuff. That's why I didn't find it. So let's change this to work stuff. Run that. And there you can see the records that were returned. So this is one way to gain insights into what's happening. Now, it does a lot more than this. So let me close these out. And we're not going to save that. I'm going to come back to Visual Studio and show you one other aspect, and then we'll jump into some more of the new features. And let me just pull up my Teams again, make sure I'm not missing any questions. Okay, so one of the aspects of EF Core is the ability to translate these link queries for you. Another aspect is how it keeps track of changes. There's a pattern called unit of work, which basically determines that you load some entities, you manipulate those, and then you either commit or roll back those changes, and all those changes should be captured. Entity Framework Core provides a unit of work out of the box, and I'm going to show you what that looks like. So right here where I have these saved changes, I'm going to put a breakpoint right here. I'm going to run it again, and this time we're going to specify a watch on that debug view. But instead of watching the query, we're going to watch something called the change tracker, which is that built-in facility to track changes. So I'm going to say context here dot change tracker, and then when I expand that, we've got a debug view. And then it has what's called a long view and a short view. And a short view is just an abbreviated version of what I'm about to show you. So you can see here, this view is showing me everything that's going on. We've got multiple entities. They have this weird negative ID. This is because we're waiting for the database to assign the ID for us. SQLite and SQL Server have mechanisms for generating next up IDs. So we haven't really done anything with the database yet. So they have these just temporary values. And you can see everything is in pretty much an added state. So let's zoom out, close this, and pull the trigger on Save Changes Async. So I'm just going to step over. Notice that this turned red because it changed. And if I expand it now, and I'll zoom in for you, now you can see we have actual IDs. And everything has gone to an unchanged state. So it's still tracking these entities. It still would let me manipulate those if I wanted to, but it recognizes that they're unchanged from the last time they were saved to the database. Then if we step over one more time, I know you can't see it in the zoom, but I just wanted to show you this is now empty because we just cleared the change tracker. So this is a feature that is useful for running demos. It's a new feature that was introduced in 5.0, but that tells the change tracker stop tracking anything that you may have been tracking before. So let me stop that. And I'm going to close out of Visual Studio and jump back into Visual Studio Code for the rest of this. Let me close this console window over here. Okay, so I showed you the debug view for the query. There are a couple other ways that you can monitor what's going on as well. One of the things that we added is something called toQueryString. So I'm going to say actual query equals work context query toQueryString. I'm just going to write that out to the console. Let's go ahead. Let me make sure I don't have any breakpoints. Let's go ahead and F5 run this. Going to expand this, drop down. And here you can see that exact query that we saw earlier is now written out. So this is a facility as you're troubleshooting, you want to figure out how it's going to translate to a query. toQueryString will give you that exact text that you're looking for. Finally, there's one other way. Now, previous versions of Entity Framework Core allowed you to do things with logging, and it used sort of the built-in logging mechanisms that are popular if you've worked with ASP.NET Core applications. You're familiar with iLogger and iLogger Factory. So you can do this configuration, you can use your app settings and you can configure those. But sometimes you want just a really simple, easy way to see what's going on. Maybe you're in a development cycle and you don't want to necessarily configure complex logging. You just want a quick, just show me what's happening. So the way we can do that is up top where we set up our options. In Entity EF Core 5, we added something called log2. And log2 is a very simple logging mechanism. You just give it a delegate that takes a string, and it will basically pass the string to that. It can also take log level, etc. And it will just start streaming logs to whatever you specify here. So for example, I'm just going to say console write line. So I'm telling it as you get logs, send them to the console and send them out. Let's hit F5 once again with just that simple change. And now as we scroll down through the code, we're going to see a lot of information. So we've got contact was made in a shadow state. So remember when I defined my DB context, I didn't explicitly put the meeting attendee. I said Entity Framework would figure it out. So this is saying, hey, we figured it out. We created it, but you didn't explicitly ask for it. As we come down, it's initialized the context. But more importantly, I want you to see that this will show the actual SQL that it's using to check the database, insert new entries into the tables. That's what we're seeing here. And if we come all the way down, there's a lot of information here. We can see, so here's our inserts that are taking place, and we'll eventually see the query that we use to get the data back. So all of that information is being logged and is available. And there are dials that you can twist and configure so that you only see logging for a certain level, if that's what you so desire. Okay, so we've talked about some of the new diagnostics or troubleshooting features. Let's get into these heavily requested features. The first one I'm going to show is a pretty straightforward one, and that's something called filtered include. So what I asked for here is I said, give me contacts with meetings, include the meeting details, where that contact has any meeting that's a work meeting. The way that played out, the result that we got was we got a list of my meetings, work stuff and bank meeting, and then we got a list of Maria's meetings, work stuff. Let's say I'm only interested in the work related meetings. What I can do is when I'm telling it to include the meeting details here, the meetings, I can add a where. Remember, this is the link table, so I do m.meeting.name equals workmeeting.name. Now it looks like I'm adding the same filter that I did down here, but remember this filter is on the contacts. That's why we see this c.meeting. So it's just filtering contacts that have any work meetings. This is actually filtering the meetings themselves. So down here where we had work stuff, bank meeting, and work stuff, if we run it with that change of the filtered query, let's go ahead and launch that out. And we should be done. I'm going to take it down to the bottom. Let's expand this up. You can see now it just got work stuff and work stuff. And if we looked at the query, we could see that. So that's a new feature of being able to filter your include, so the related entities that you're pulling in, you can also filter like this. Now the next one is a huge feature that a lot of people requested and have been waiting for, and that's something called many-to-many. And many-to-many refers to the configuration of how you so I'm just going to delete that code because meeting. That's the change I'll do there. A meeting should have multiple contacts. So instead of using this weird meeting attendee table, I'm just going to say this as a contact. Now this is not something you can do in previous versions of EF Core. I've made that change. Now I've got some updating to do because here, now this meetings is not that weird link table. This is the actual meetings table. So I'm just going to get rid of this middle and go straight for the name. We don't need this then include because we're just referencing the table directly. And this can reference the name directly as well. So I've just deleted a ton of code and simplified things. If we come down here, we can see where we're printing things out. We no longer need to do this meeting.meeting. We can just say meeting name. And then finally in the setup's a little different because instead of creating these meeting attendee instances, what I can do is I can say this meeting has a set of attendees, which is a list of contacts that includes Jeremy and Maria. And this meeting has a set of attendees. And those attendees are Jeremy and Doreen. Then I can delete all of this. And when I'm adding this to the context, there's no longer these classes, so I can go ahead and get rid of them. Vastly simplified the code that I'm writing. And I just want to point out two things here that EF Core does for developers who are working with databases. One is it immediately understood because I added this list that I'm establishing a relationship. So I can just do a natural set of coding idioms, if you will. I can just naturally add that list and EF Core will handle it. It also doesn't make me do extra work. In other words, I have a collection of meetings under contact, but I don't have to put it in both places. One is enough. I could come here and say new set of meetings and specify them, but that's just extra work. It is enough to specify it on one side and it knows that it's on both sides. So let's run this with the changes. And it's running through, so if everything went well, we should get the exact same result at the end, which we do. We get my meeting, work stuff, Maria's meeting, work stuff. So we got the same result with simpler code. Let's see what happened in the database. So I'm going to refresh this. Let's close it and reopen it. It's probably the easiest way. So now if we look at the database, we can see it's created this contact meeting. I didn't define this. I don't have a class called contact meeting. It was just automatically created for me and has those values in it. And then I have my contacts. You can see those over here. And I have my meetings. You can see those over here. That is many-to-many. Now, one of the things that can happen or come up is I may simplify my code like this, and then my manager comes to me later and says, we need to track if someone accepted the meeting or not. So we need information about that union. It's not information on the contact. It's not information on the meeting. It's information on that join. That contact accepted this meeting. So how can we do this? Well, NED framework allows me to configure this, and I could go back to creating that artificial join table, but chances are I may only need this on the database side of things. I may not be writing logic in my code that deals with it. So what I can do is where we, define our data context, I'm going to add a little bit of code. I'll show you what that code looks like. And so that I can spare you watching me type and fumble, I'm just going to do the fastest typing you've ever seen and really quickly, boom, drop that in. And then what is it, Alt-Shift-F to format it in. So there is a method called onModelCreating. This is where we're telling NED Framework how to map the domain or business objects to the database. I'm telling it that a meeting has many attendees, an attendee has many meetings. And I would like it to use an entity, and here I can give it a type. And if I had a class, I could do it, but NED Framework Core is smart enough that it can deal with multiple types of CLR objects. In other words, you don't have to define a class specifically for this. I could just use a dictionary of string object. I'm giving it the name meeting status. And I'm saying it has one contact and one meeting, and there is a property on it called accepted. So here, just through my database definition, I've defined that extra field. If I run this code now, it's going to give me the exact same result that we saw before. And let me just scroll down here and show you. So we got work stuff, work stuff. But here, if I refresh, I don't know why my refresh isn't showing here. Let me close it and open it again. Probably because I'm deleting it and recreating it, so it's losing that context. But if we open this, now we'll see that we have this meeting status. So instead of contact meeting that I called it before, it takes the name I gave it. And if we look at this, it now has an accepted field. Now, having done all that, you're probably thinking, well, if you're just using a dictionary, how on earth would you ever update this if you had to encode? Again, we could introduce a C# class, map that class, and have that work. Or we could take advantage of the fact that Entity Framework is extremely flexible and can handle multiple types. So what I'm going to do is accept the bank meeting for me, and I'll show you one way that I can do this. And again, this is just here to show you some of the flexibility. It's not meant to indicate, this is the best coding practice or how you should approach it, just sharing with you options. So here what I'm doing is I'm telling the context that I would like to reference an entity, and that entity is just going to be this dictionary of string and object again. The name of it is meeting status, and I want it to select one where the meetings ID is the bank meeting and the attendee ID is Jeremy's ID. So here I'm just taking that dictionary of object, casting it to an int, and this is the flexibility. This link query can get interpreted, parsed, and translated by Entity Framework. And then I'm just telling it set the status accepted to true. Now that will update the unit of work, but we have to commit it to the database. So the next thing I want to do is save it. So I've just referenced it and manipulated that status. Now we'll run this again, and I'm going to be preemptive and go ahead and close this, run this. And it's finished running. I'm going to assume it didn't blow up. Let's open our database again. Look at meeting status. And here you can see it's updated this status to a 1. So I have that flexibility of using my C# classes or even just mapping it to something generic like a dictionary and fluently defining that relationship on the back end. So those are just a few examples of how Entity Framework works. Now there's another example I'd like to show you of another requested feature, which is called table per type. Now, previous versions and the default that Entity Framework Core works with is something called table per hierarchy. And what it's referring to is how you're defining your C# classes. So let's come down here, and here's our contact. I'm going to derive a Microsoft contact from contact. So this has all the attributes of a contact, but the difference is I'm going to introduce an employee ID. So I'm going to make an int employee ID get set. That's the only additional piece of information. Where I define my name up here, I'm going to change this from a contact to a Microsoft contact and give my employee ID. Didn't think I'd give the real one, did you? And then the only other thing, if I just left it like that, it would never save the employee ID because I haven't told EF Core about Microsoft Contact. I've only told it about Contact. In other words, in my DB set, I have this contacts, but I need to tell it that it should be interested in Microsoft Contact as well. So right here in my model building, I'm just going to say builder entity Microsoft Contact. And that's it. I've just informed EF Core that I'm interested in it keeping track of Microsoft Contact. So let's run this. And this is using the default behavior. So let's close this out, reopen it. And what we're going to see is in our contacts, it's now added 2 fields. So it still just has 1 table, but it's added this discriminator and this employee ID. If we look at this, you can see now it's basically overloaded the table to have employee ID. It's null for the ones that are ordinary contacts. And then it's storing the type in this discriminator column. So now if I ask for just Microsoft Contacts, it's got a column that it can query on. And this is table per hierarchy. So if I derive multiple levels or I have multiple class, I have a Microsoft Contact, a Amazon, Oracle, Google, anyone in the tech industry, Facebook, Twitter, those will all just have discriminators in this table. Let's say for whatever reason that I want to have separate tables. Maybe I have an existing database that defines that information separately, or maybe I have a really wide set of data, so I don't want this wide table with many columns. I just want the columns where it makes sense. Now, there are going to be trade-offs if I take that approach, because the query now has to join multiple tables. If I'm just saying give me all contacts, it's going to have to go to contact table 1, 2, 3, 4, 5 and do that. So that can have an impact. So you have to be aware of how this is working underlying. But it used to be you could only use this table per hierarchy. To do table per type, I just make a simple change. I'm going to say to table name of Microsoft Contact. And I could really give it any string there, but I like to use strongly typed, so this will work for me. That's it. I'm just telling it, give it its own table. We'll run this again. And we will close and reopen this database. And now you can see we have a contacts table right here that just has name in it, and we have a Microsoft contact that has that one entry with the employee ID. So now it's separated out, and that is a table per type. And it's not either or, it's all or nothing. In other words, you either do it all table per hierarchy, or every derived type gets its own table. Now that doesn't mean you can't use the base type for querying. It just means that you have to map these to a table. So let's, I'm just going to check the Q&A quickly. Can I talk about UI scaffolding? So unfortunately I can't for 2 reasons. One is we're pressed for time. 2, there's not really a UI for scaffolding for EF Core. So we have a CLI command line interface, and we have a NuGet package manager console set of commands. And let's go back to the documentation here. So there is, what we're talking about is when you scaffold a database, what you're doing is looking at a database and asking it to generate the classes based on that database. So if we look at create a model, manage database schemas, this section gives you everything you need to know about scaffolding, reverse engineering, if your database is the source of truth. And the migrations documentation has actually been updated to be very detailed on how you handle those schema changes. Now, if that's not what you're asking, if there's a different question about UI scaffolding, feel free, but I think what you're asking is how we do this step of basically scaffolding the code from the database. So this is covered in the documentation, and it's very, very detailed. The team spent a lot of time overhauling this. I'm going to cover just a couple more new features here in the last few minutes we have. One feature is we've added events so that you can hook into interesting events that happen with the data context. So for example, one of those would be saving changes. So I may want to trigger some code every time that the changes are either about to get saved. For example, maybe I want to add audit code, or after the database has been successfully saved. So what I'm going to do here is just right after I create my DB context right here, I'm going to add this piece of code. I'm telling it I want to hook into the save changes event, and I want you to say saved, and you can see these arguments I get gives me the entity saved count. Let me just hover over this so you can see I've got entity saved count and accept all changes on success. But what I can do here is I could go into the context. I could look at the change tracker. I could look at the entity list, etc. I'm just keeping it simple for this. And I'm going to take off the log2 to get rid of any background noise. So if we run that, and we come down here, past all the lovely yellow, you can see it saved 10 entities. So this is where I set up the initial set of contacts and meetings and their relationships. And then you can see we have saved one entity, and that is when I updated the status to accepted. And then we have my console log. That is one way to intercept save changes. The other thing we have is a concept of interceptors. And there's multiple types of interceptors. And an interceptor is a piece of code that you write that gets sort of plugged into the pipeline that EF Core is running. So the first one I'll show you does a similar thing to the save changes event. And let me just pull that code out for you. And let me copy that. Just making sure I have the right example for you. Okay. And we're going to use some magic in Visual Studio Code. If you work in Visual Studio Code and aren't aware of some of these shortcuts, I'll share them with you pretty quickly. Let's go down into our namespace, and after the DB context, I'm going to add this, and you see all these red squigglies. So it's not liking it because I need some includes. So I'm going to come over this, and I'm just going to do control period, and that tells me, oh, that's in diagnostics. So we take care of that. That gets rid of most of the squigglies, but then we have this piece here, which is part of the threading tasks. So we'll get that using statement in. And then we have this cancellation token, which is part of threading. So what did I do? I basically, and then we do Shift-Alt-F to format. So I inherited from the save changes interceptor. So there's a new base class that you can use that implements this functionality. So then I can override saving changes and saving changes async, because there's both. And I happen to not use async code in these demos just to keep it simple and focus on the new features as opposed to getting into asynchronous code. But know that EF Core supports both styles of programming. So when you implement this interceptor, you implement it both in the async and the sync context. Now I'm just calling the same method here, and that is event data display, and it's showing event data ID, event data.event ID code, etc. So it's pulling out some information from this. So defining the interceptor is not enough. I actually have to plug it into that pipeline or that workflow. So right here, I'm going to say add interceptors. And then it's going to ask me what I want to add, and I'm going to add a new save changes. Oh, interceptor right here. Oh, it was actually impl. It was the implementation of it. Okay, so now that's added into the pipeline. So now I can run this one more time. And we can look at the code that was generated. And here you can see it was called, it gave me starting contact ID, meeting ID. So it's basically given me all of that state and context based on it being added. And then this is the original event. So those are two different ways that you can do that. Now, obviously, the method where you define a class is going to give you more flexibility and more reuse. Now, these interceptors can also do things like intercept database commands. So for example, I could intercept a query or even a update statement before it gets sent to the database and manipulate it in some way. For example, and again, not recommending this as the best practice solution because multi-tenancy has a lot of different things to solve, but you may have a context that you know a person's in a certain tenant, and you may want to use an interception to do that. Now, there's other things called global query filters, etc., that can handle that. So let me drop out back to what's new in EF Core, and I'm just going to review a couple of these and then close it out for final questions because we're at the top of the hour. So split queries is one that is providing more flexibility in some of the queries that had really poor performance in previous versions of EF Core. And as an example, let's say you have a massive list that you're correlating to another massive list and you're doing a join between them with multiple levels. Well, what can happen is that join can bring back a massive amount of record sets and create an issue with how that query is basically resolved. With split queries, notice here, so this is doing a join, and with this type of join, you're going to get a huge stack, and depending on how the join is defined, you might get 1 to the n or 2 to the n or whatever number of entries back. When you specify a split query, what EF Core will do is it'll issue a query off one collection, a separate query for the other collection, and then it'll join them in memory. And in some scenarios, that is better performance and even better memory management than doing it directly. I talked about the logging and diagnostics. I talked about filtered include, table per type. We talked a little bit about flexible entity mapping, that we can do things like map to different tables. We've got flexibility over table per type. We can even use dictionaries if we want to. That's this property bags and shared entity types. We've got required dependents. So this is basically specifying a condition for the model to work correctly. And then this is one that I wanted to touch on before I close out, and that's the DB Context Factory. For those of you who are building Blazor applications, Blazor is unique in how data contexts are managed. In desktop applications, it's not uncommon to load a DB context, bind it to the UI, and let the user manipulate the UI, and then just call save changes. So that's a long-lived data context. And it tracks all those changes, and it does everything that's needed. When you're an ASP.NET application, it's very transactional. In other words, user submits a form, you're not holding on to a data context while they submit the form. You're grabbing the data, presenting it. Then when they make an update, you're sending that data back down. Well, what what Blazor does is it is sort of a hybrid where there's state being maintained in the browser or on the server, but you have this concept of a circuit in SignalR where the lifetime of it should probably be shorter lived, but isn't always. And there's an entire article about it on ASP.NET. But to make a short story boring, what we recommend for Blazor apps is that you create a context and destroy it for every operation. So if you're doing a query, if you're doing an update, we recommend you create it, use it, and get rid of it quickly. In order to do that, dependency injection is just going to hand you a copy of that DB context. But you need to be able to spin up multiple copies if you're following this pattern. So what we introduced was this DB context factory. And what you can do is you can configure the context factory so that every time you ask for a DB context, it gives you one that's configured the way you want it to be configured. It will also do something called pooling, which is some shared context, and there's a lot of flexibility there. But just know that that's a new feature that was added too with that factory, that you can inject the factory and then ask for new copies of the DB context. And there is an article, in fact, I think if you just search for ASP.NET Core Blazor DB context factory. This article right here, ASP.NET Core Blazor Server, this will walk you through with a sample app exactly how that works. So we are at the top of the hour. I promised a lot of code, a lot of demos. I only had one slide. Again, my name is Jeremy Likness. Let me pop back to the slide so you can reach out to me on Twitter if you like. Feel free to ask some final questions. I'll hang around. In fact, I see we've got some new things that came in, so let me just double check those. Looks like EF is Django-ish. I'm not familiar with that, so I can't answer why. Will the future version include a complete Django implementation with MTV admin, etc.? Again, I'm not familiar with I think I'm pronouncing it right, correctly, Django, so that is not one that I can answer. Okay, well, I will look for additional questions. This will be recorded and the link has been posted, and there's a survey that we'd love for you to fill out. Feel free to reach out to me if you have questions. Our documentation covers everything, aka.ms/efdocs. Thank you so much for your time and your attention this evening. Appreciate you.